Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Vestiges of an Epicycle Castle by Dubious Mobius and AQJHS. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. We also have to draw a loop that moves orthogonally, which means it goes either horizontally or vertically. It can never go diagonally. And it can touch itself, but not cross itself or cover a cell more than once. So it can touch itself. So you could have something along the lines of a loop, something like this is valid. Right? That's valid. But it cannot cross itself or essentially do, like, it can't go like, um, what it cannot do is something like, I don't know, like this, right? Oops. It can't go diagonally either. So something like this is not allowed. It can't cross itself here like that, and it cannot cover a cell more than once. So it can't go like here to here to here to here to here. I don't even know. I can't go like this, I guess. That would be the way. So that's not possible. Because it would be crossing itself and covering a cell more than once. So, but this one is valid here. Cells marked with arrows, circles, or squares may not be on the loop. So these cells with arrows, circles, or squares cannot be on the loop. So this is actually not valid because this cannot be on the loop. Cells marked with a circle must be inside the loop. And cells marked with a square must be outside the loop. So this loop doesn't work because these squares have to be outside the loop. And the circles have to be inside the loop. Oh, that's interesting. That leads to a certain way it has to go. The loop has to go, essentially. Okay. A cell with an arrow contains a digit that indicates the number of line segments in that direction. That is the number of times the loop crosses a cell border traveling in that direction. Okay. So this is not correct because this was supposed to be vertical arrows only count vertical lines and horizontal arrows count horizontal lines. Wait, what? Huh. Okay. A cell with an arrow contains a digit that indicates the number of line segments in that direction. I'm still confused about the vertical arrows only count vertical lines. Um, Hold on, let me pause and see if there's a clarification on that. Okay, I understand what it is. So for example, this 3 says that the loop will cross 3 specific. Actually, it's pretty specific here. Well, the loop has to cross 3 borders, essentially, in this direction. So that's why this loop doesn't work, actually, also for the arrows. Because this is saying the loop must cross 3 boundaries in this direction, 3 cell borders in this direction. and it's only crossing 2 right now, 1 and 2. So that should tell you some information there. And vertical arrows only count vertical lines, so this only counts these. So it doesn't matter that it's crossing this way, those don't count, right? So these two would not count toward the 3 that's counting. It's specifically counting edges, cell borders that the line crosses vertically. So that should tell you some information. And horizontal arrows only count horizontal arrows count horizontal lines. So basically the lines that are moving horizontally for the loop. That's what it would count there. And that's how arrows work. So circles also have to be inside the loop, and squares are outside the loop. So these are incorrect. Obviously this is incorrect because it has to be inside the loop. These squares have to be outside the loop. That's actually very interesting there. And that's how circles, squares, and arrows work. The loop is a mod length region sum line. What does that mean? Box borders split the line into connected components. Cells on a component of length L with a digit D have a value equal to the remainder. Okay, so it's of D divided by L. Okay, so this would be essentially 7. So the length L So box borders split the line into connected components. Okay, so this is a component, this is component, this is a component, this is a component, that's a component, this is a component, etc., etc. Cells on a component of length n, so of length L, with a digit D, have a value equal to the so the value is equal to the remainder of D divided by L. So each of these cells would essentially have okay, that's very interesting. Each of these cells, since the L is 7 here, would have their value is equal to the remainder of their digit divided by the length of the component, which would be 7. So if, for example, this was, say, a 9, the value of this cell would actually be 9 mod 7, which would be 2, right? If D is a multiple of L, then the cells has value equal to 0. So again, if this is 9, since this L is length 7 here, because the length of the component is 7, this value of this cell would be 2. Similarly, if this were 2, this would also be a value of 2, because this is the value is 2 mod 7, which is you have a remainder of 2 here. If this were, say, a 3, that value would be 3 mod 7. And I guess that's interesting. So this is length 2. So if this were a 4, this would have to be a value of 0, because it's 4 mod 2 has a remainder of 0. And if this was like, say, 9, this would have a value of 1, because it has a value of 1 specific. 9 mod 2 is a value of 1. And then all components have the same value sum. So if you sum up all the values of the cells, it should be equal. But obviously this is not going to be equal, because this is only a value of essentially 1. And this is already a value of 7 here. So that this wouldn't work in general anyways. Just for this specific example. Because all components have the same value sum. Interesting. Interesting. This is I've never seen this rule set. That's pretty cool. Okay, so cells joined by a white dot have consecutive digits, and not all possible white dots are given. So, for example, if this was a 2, this has to be 3, or it could be a 1, because it just has to be consecutive with this digit. And that's all we have. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so like we said, this line must pass through these three cell borders, right? Because otherwise, it doesn't count toward the arrow. So this has to go this way, and then it turns here, or it turns here, or it turns here and turns here. It cannot turn here and here. It actually could turn here and here potentially, actually. So, Actually, if it turned this way, it actually could continue. Oh, we don't even. Oh, this is not on the loop. So we know all the arrows, all the arrows, all the circles, and all the squares are not on the loop. So these are not on the loop. These are not on the loop. This is not on the loop. So this cannot go this way. That's why we know these three have to go this way. So these three are on the loop. If it goes this way, there's no way that it can go back here and go exit back out and exclude this from inside the loop, right? If it goes this way, it essentially has to enclose this cell, and this cell is supposed to be outside the loop. So this can never go this way. It has to always go this way. And so it cannot go this way either, right? Because then that encloses it this way here, right? If it tries to go this way and that way, that forms a loop, but the problem is that these arrows say that there have to be segments along those loops. So therefore, this has to be some segment this way. Some segment this way, some segment this way, some segment this way. So if it goes both this way and this way, this is not allowed, because this would form a small loop by itself, but it wouldn't be one large loop. So therefore, and if we try to go this way and try to go this way, the problem is this is going to be inside the loop no matter what, because this one cannot cross, so it would have to go something along the lines of like that, and that would enclose this, which is not allowed. Therefore, it must go this way, and it must go this way. So this is going this way, and it goes this way. This cannot go this way, so it has to essentially go in some direction this way. This could go up, we don't know. This one essentially has to do something like this. It cannot go in here. Well, I guess it could, technically. It could go something like that. But it can't go this way. So this one's out. This is not on the loop. If it tries to go here, the problem is it would have to continue here, and this would definitely be inside the loop. So this is not on the loop. Okay, so it cannot go up here. If it tries going up here, this one has to essentially go somewhere this way, and that blocks this. So this has to be on the loop, because this one has to be able to get here. So therefore, this is also on the loop, and it has to go this way. So it has to go this way. This one has to go this way. So this is on the loop. So either both of these go this way, and then this would go around, or both of these go this way. So this one, okay, so it goes down here. It essentially does have to loop around here. So we know either it goes down here and then loops here, because this has to be inside, or it goes around this. So both of these go either down, and this goes there, or they both loop this way, and then this has to go around that way. So either way, these are on the loop. So these have to be on the loop. We don't know if it extends down here or if it goes this way. These cannot be on the loop because it can't enter anymore and then exit out of that loop. It has to go this way, but we don't know if it connects. So these sections don't necessarily have to connect. This could go down, and this would have to go that way. Or this goes this way, and then this way, and then this goes around this way. We're not sure which. So this has to be, well, we don't know. So this is 1 crossing here, 2, 3, 4, right? So this crosses 1, this crosses 2, this crosses 3, this crosses 4, but this cannot be 4 here because of that 4. So this does have to cross here, another one for 5. Therefore, these are not on the loop. This must be a 5. This is either 2 or 3. We're not sure which. So it's either, this is 2 already, and it could be a third one here. This is at most 1, 2, and 3. So this is 1, 2, or 3. This is at most 1, 2, 3, 4, 5. So this is at most 5. And this is at most 1, 2, 3, 4, 5, 6, 7. So this is 7, 1, 2, 3, 6, 7. This has some. So it would have to have something like this if it goes down. Well, not necessarily. It could go something like that. So this is at most 1, 2, 3, 4, 5. So this is 1, 2, 4, 5. I'm gonna pause. I need to go to the bathroom pretty badly right now. I'll be right back. And I'm back. Okay, let's continue with where we were. Let's see. Interesting. Okay. So this segment can be at most 2 in size. Right? Because it's L is length 2. And the digits you could have are odd digits here, which would give the value of 1. Therefore, this length has to be at least at most 2. So if it were 5 length here, I don't think you can ever have a 5 length that would match a 2, right? If you have 5, you only have one that's size 0, right? It's 5, which is 0 mod 5. And then you could have at most 2 1s there, and then you would have 2 2s. So you can't have a length in any box contiguous, a length 5 or more segment. So this has to go down here then. This could go here and then go back here. We actually don't know about that, right? But this one specifically has to go here. It could actually go back in. We don't actually know. But it cannot be more than 4. Right? Because if you have more than 4, again, you would have 5 digits here. Therefore, it's mod 5. You could only have one that's mod 0 mod 5, which is 5 itself. And then you would have two that are mod 1 mod 5, which would be 6 and 6 and 1. And then everything else would be greater than 1 mod 5. So these both have to be odd. These both have to be odd. So we have all the odds here. So this is 1579, and these are 1579 because these both have to be 1 mod 3. These can be, you have at most 0. So one of them, you have to have 2 0 mod 3s, which is 4 and 8. So 4 and 8 have to be here. And then you have to have 2 1 mod 3s, which would be 1 and 5 or 9. And that would add up to 2. And that's a 2, and that's a 2. These cannot be 5, though. Okay, so these cannot be 5. This can't be 5. Therefore, one of these two is a 5. This can't be 1 or 5 because the rest of the box has to be 2, 4, 6, and 8. Well, this can't be 5 either. So the 5 has to be one of these 3. So we have a 1, 4, 8, 9 quadruple in box 1 then. Which means this could be 2, 3 to be next to 1 or 4. And it could be, if this is 4, this could be 5. If this is 8, this could be 7 or 9. It can't be 9 because we know the 9's here and we know the 8's here in these 4 cells. So this cannot be 7, 8, or 9. So therefore, this can't be 9 specifically. 2 has to be one of these digits here. And if the 2 is here, and this was size 4, length 4, that would already include then a 2 mod 4, which would have a value of 2. So this would then have to have a value of at least 0 mod 3, which would be 4, and 0 mod 3 if it were... So if this is length 4, you'd have a 0 mod 4, which is... which would be 4, and another 0 mod 4, which is 8, but a 2 mod 4, which is 2, and then at minimum a 1 mod 4, which doesn't add up. So therefore, this cannot be 4 here. It has to exit out. So it exits out, which means this cannot be in the loop. This exits out. So this has to include a 1 mod 3 and a 0 mod, or sorry, a 2 0 mod 3s. Oh, actually, we know exactly what it has to be. It has to be 2 and 6. So this is 2 and 6. One of these is 7, so this can't be 7. All 4 and 8s have to be in box 1 because they can't be here, here, or here. So this is a 0 mod 3, so it's 2 and 6, and then 2 mod 3. So therefore, this must be another 0 mod 3, so it's 3 or 9. But we have a 4 and 8 have to be in one of those 3 cells, or in these 3 cells specifically in column 2, because they can't be anywhere else in column 2. So therefore, this can't be 4 or 8. We have a 1, 9, 1, 5, 9 triplet in column 3, which eliminates 1, 5, and 9 from the rest of the column. Therefore, this can't be 9. This has to be a 3. Okay. This cannot be anything. This cannot be size 4. Obviously, again, no segment can be size 5 because these segments are essentially 2 in length. So therefore, this cannot be 4 because well, I guess it could contain that 4. So it could go that way. That actually could work. Never mind. So it could actually be 4 here. Okay. So this is two total. This is 2. This is 2. Hmm. So if these go down, this one would have to essentially, well, this one would have to go down. Well, they could actually touch, so that's fine. So it could actually go that way too. Hmm. This digit is 1 through 7, but it cannot be 2 or 6. So it can't be, so it's already 2 here. So it cannot be 2, 3. It's 4 or 7. Oh, that's interesting. Okay. This one has to be surrounded because to loop it in, you have to go from this way and surround it that way. So these are on the loop. So it has to connect somehow this way. Again, this cannot be more than 4. So it cannot go all the way up here and there. It cannot go down. It actually has to specifically go this way. So we know that for certain. It specifically has to go that way. And so this already sees 1 and 2. So this can't be 1. This has to have 4 and 8. And it has to have 1 out of 1, 5, or 9. Okay, so this is 1, 2, 3, right? So we have 1 cross, 2 cross, and 3. So this is 3. This cannot be 4. This cannot be 3. So it enters here. So it could be something like this. Well, it could be 4 here and then exiting out. It could be 2 here and then 4 here. That's fine too. Or it could be 2, 2, and then exit, and then this would be 2. Ah, but if this is 2, 2, and 2, that doesn't work. Because there's only 5 odds in a every box, and this is 3 already. So one of these needs to be 4, and the other needs to be 2. So it's either 4 here, and it exit out, or it's 2 here, then it's 4 here, and then exit out. So it's either 4 this way, and 2 this way, or if it's 2 here, 2 here, and then this is 4. Well, okay, so this cannot be 2 odd digits because we already have 4 odd digits in the column. So it cannot enter in here and then exit back out. So this has to connect here, which means this must exit out here. So this is part of the loop. None of these can be part of the loop because if it enters in, it will never exit out again. So this has to exit out this way. And we don't know which way direction it exits out. It could exit out here and then connect. These are not part of the loop. This one actually, well, cannot enter in because then that would be 1. Oh, and like, yeah, this is at minimum a value of 2. So therefore, this always has to be 1 and 1. Just to make sure that you know that. This sees 3. So it cannot enter in and then exit back out because this can never have a value of 2 then. Same here. Well, this could actually still connect this way. This can never go this way. But it could do some weird... Well, even then, that funky stuff doesn't really work. Okay, so this cannot actually go this way, because that would form a single loop by itself, and then this would not be one large loop. So this has to go this way. We don't know if it connects to here or if it connects further. Well, say it did connect to here. The problem is, again, you would still run into, so this would be length 4 with a 2 mod 4 in it on the loop already. So then you would have a minimum 0 mod 4 and another 0 mod 4, and then a 1 mod 4 at minimum. So that would value equal value 3. So this could not connect. This cannot go this way and then be length 4 segment. So it must connect here. So this has to connect here, which means this cannot actually go all the way. It has to go all the way down because if it goes this way, then this is inside the loop. So this has to actually go this way. So it has to go here, which means this cannot go here, this cannot go here, so this is not on the loop. This is 3. It could be 1 mod 3, 1 mod 3, and 0 mod 3, or it's same here. So this is sees 1 and 2. So this is 2. This has to be length 2 at least, because it cannot be any less. So it has to go here, which means it must then go that way. If it goes this way, this is already a size 5 loop, then if that's the case. So it cannot go here. This one could go this way. We don't actually know. This is size 2. So this has to be an odd digit. So it's 1, 5, 7, and 9. These have to include a 4 and an 8. And then it also has 2 1 mod 4s. So we have a 1, 4, 5, 8, and 9. 1, 4, 5, 7, 8, and 9 quintuplet or sextuplet in box 2, which eliminates those digits from the rest of the box. Therefore, that leaves 2 and 6. So it's 2 and 6 here. This sees 0 here, so that's 1 at least. It has to see 2 then. Cannot see 1. So this is 2. These cannot be 2. We have a 4, 6, 8 triplet in column 1, which eliminates 4, 6, and 8 from the rest of the column. Therefore, this is 7. So this can't be 7. That means this can't be 8. This then says there's 7 lines this crosses, so it has to go 7 here. And that's the max. So it has to go this way, which means none of these are valid. This one then has to go at least here. So that's 1 cross 2, 3, 4, 5, 6, and 7. So that's how we know it's 7. Then this has to go up. So it goes here. So that's at least 1, 2, 3 crosses. So this can't be 2. It needs to have, it can only have 4 at most, so it must exit out that way. So it must cross here. So that's not, it's greater than 3 then. So it's 1, 2, 3, 4, 5. So this has to be 6. It cannot be 7 because this last one's not crossed. So this is 6 because it can't be 4 or 5. Therefore, this goes all the way through. It cannot just connect this way. So it cannot go here because it cannot go there anymore, and this is all connected. So this is at most what? 1, 2, 2. So this is 1 or 2 here. So 2 and 6 cannot be here. 2 and 6 cannot be here. Where are the 2 and 6? They have to be here and here. So this is 2, this is 6. This has to be a 2, 6 pair then here, and therefore this is 2, which makes that 1. This has to be 6, because that's the only possibility there. One of these is 5. We have a 1... None of these can be 1. We have a 4, 5, 8, and 9 quadruplet in row 2, which eliminates 4, 5, 8, and 9 from the rest of the row. So this must be a 7. Therefore, this can't be a 7. This has to have 2 going down this way, so therefore these are all on the loop, and it has to go this way. And this is not on the loop. Okay, so now it's just filling out the mod situation, right? This is 4, so it has to have a 4 and 8, and it has to have a 2 out of 1, 5, and 9. This is all. This cannot be. Well, we don't even know. We don't know about 1. We have a 1, 4, 5, 8, 9 quintuplet in row 3, which eliminates 1, 4, 5, 8, and 9 in the rest of the row. So this can't be 5, which forces this to be a 5. And the remaining digits are 3 and 7. And this can't be 3, so this has to be a 7, which makes that a 3. This 1 means this can't be 1, so this is 9. And this eliminates 1 and 9 from these columns. This can't be 1, this can't be 1, and these can't be 9. Okay, this is 4, 6, and 8, so the remaining digits in the column have to be 1 and 9. So this is 1 and 9, 1 and 9. Same here in column 3, the remaining digits are 4 and 8, but this can't be 4. So this is 8, which makes that a 4. This can't be 4. These digits both have to be odd to give you a 1 mod 2 in both of these cells. Same here. These both have to be odd also. So therefore, this is 1, 3, 5, 7, or 9. We now have a 1, 3, 5, 7, 9 quintuplet in row 7, which eliminates 1, 3, 5, 7, and 9, which are all the odd digits in that row. Therefore, this cannot be 1, 5, or 9. It has to be 8, which means these can't be 8. The remaining digits here have to be 2 and 6. But 6 cannot be here. 6 can't be here. So one of these is a 6. We're not sure which. This is an odd, right? These two have to be odd. And this can't be 7. So this has to be 1, 3, 5, and 9. We have a 1, 3, 5, 9 quadruplet in column 6, which eliminates 1, 3, 5, and 9 in the rest of the column. That leaves only 8 here. This is a 2 mod 3. So we have to have 0 mod 3s in the rest, and 3 is already taken. So this has to be 6 and 9. Because those are the only remaining 0 mod 3s left. So these can't be 9. This is 1, 4, and 5. This can't be 6, so that forces this to be 2, which makes that a 6, which makes that a 2. We have a 1, 4, 5 triplet in box 9, which eliminates 1, 4, 5 in the rest of the box. Also, these can't be 8 here because of this 8. So this can't be 1 or 5 here. This can't be 3, and these can't be 9. 8 is one of these two, so it cannot be here. This can't be 9. This can't be 3 because of this 3. Let's see. This can't be 9. This can't be 5. 3 and 7 both have to be here. And then we have 1 out of 1, 4, and 8. But 4 and 8 definitely have to be in these 4 cells to give you 0 mod 4. So this has to be 1 then as the remaining digit. We have a 1, 3, 7 triplet in row 1 and in box 3, which eliminates 1, 3, and 7 from the rest of the row or the box. So this can't be 1. This is a 4, 8, 4, 8 pair. This can't be 1. We now have 4, 5, 8, and 9. Okay. This is already 1 mod 3. So neither of these can be 2 mod 3. There's 0 mod 3 or 1 mod 3. And we have one of each. If it's 0 mod 3, it could be 9 here, or this could be 3 or 6. If it's 1 mod 3, it's 1, 4, or 7, but we already have a 7. So it's 1 or 4 here. 8 then cannot be here. 2, actually, we know where the 2's are in box 9. Cannot be here or here. It has to be here. Therefore, we have 8 2's now, right? So we know where the last 2 is. It has to be here. So this is 2, which means these have to be both 0 mod 3's here to add up to 2 total, right? So this has to be 3 and 9 because 6 is already taken. So this is 3 and 9. Therefore, none of these could be 3 or 9. We still need a 0 mod 3 in this set of 3. So this has to be 6 then, which makes that a 6. These two cannot be 6. Therefore, where is the 6 in column 1? It has to be here. This is a 3, 9 pair. This is 1 or 4. This is 6. This is 3, 9. Since this is a 3, 9 pair, that eliminates 3 and 9 from the rest of the column. These can't be 9 anymore. Cannot be 9. So it becomes a 4, 5 pair, which eliminates 4 and 5 from the rest of the column. This can't be 3 or 1 then. Sorry, this can't be 4 or 5. That makes that 1. This can't be 1 or 3 now. So this must be 7, which means these can't be 7. These can't be 4 or 5 because of the 4 or 5 pair in the box. So therefore, this is an 8 and 9 pair now in row 2, which eliminates 8 and 9 in the rest of the row. This cannot be 9 then. So this is 4 or 5. These can't be 1. Where is the 7 in box 9? It can't be here, it can't be here, it can't be here. It must be here. So this is a 7, which means this can't be 7. That means this is 3 or 9. So now we have a 3, 9, 3, 9 pair in column 8, which eliminates 3 and 9 from the rest of the column. Therefore, this can't be 9. It's 8. This can't be 3, so it must be 1, which makes that 3. This 8 makes this a 9. And the remaining digit has to be a 4 or 5. Okay. Okay. So we have in column 5 already the 3, 6, and 9 are already taken. This is already 0 mod 3 here. If you try to have a 2 mod 3, there's no other 0 mod 3 to add to it to add so that this could add up to 2 for a mod total. Therefore, it needs to be 2 1 mod 3's here. So this has to be 1 4 or 7, and this is 1 4 or 7 here. These are both odd. That's fine. This is a 2. So these are already adding up. So we have 2 1 mod 3's here. We cannot have 2 1 mod 3's here. So if we tried to have 1 1 mod 3, that doesn't work because we need a second one to balance that out. But there's only 3 1 mod 3's in every box. So this has to be a 2 mod 3 and 2 0 mod 3's. So therefore 3 and 9 both have to be here. And we need 1 out of 5 or 8 because the 2 is already taken. So 3 and 9 are definitely here, which eliminates 3 and 9 from the rest of the box. Therefore, this can't be 3 or 9. So we have a 1 5 1 5 pair in box 5, which eliminates 1 and 5 from the rest of the box. So this can't be 5, and these can't be 1. It also eliminates 1 and 5 from the rest of the column, so this can't be 1 or 5, which makes that 9. This can no longer be 1 or 5, so this is 3, which makes that 9. That 9 means this has to be a 1, which makes that a 5. This 9 also means this is a 3. This 1 means this is a 9. This can't be 3. We have a 3, 8, 9 triplet in column 4, which eliminates 3, 8, and 9 in the rest of the column. Therefore, this can't be 8 or 9. This is a 4 then, which means this is 8, which makes that a 4. This 4 means this is a 5, which makes that a 4, which makes that a 5. There can no longer be a 4 or 5 in the rest of the row. This can't be 9. This can't be 8 again because of the 3, 8, and 9 triplet in the column. So this is 1, which makes that an 8. And the remaining digits now We have a 1, 5, 1, 5 pair in row 4, which eliminates 1 and 5 from the rest of the row. So this can't be 1 or 5. This is 4, which makes this 5, which makes that 4, which makes this 1. This 4 means this can't be 4, so this is 7, which means this can't be 7, so it's 9, which makes that 7, which makes this 4. This 1 means this can't be 1, so this is 5 and 1, which makes that not 1, so it's 5 and 1. This 4 means this can't be 4, so this is 8 and 4. This can't be 3 because of this 3, so this must be a 9, which makes that a 3. This 9 means this can't be 9, so this is 8. This can't be 8 or 9, so this is 3. This can't be 3 or 8, so this is 9. And the remaining digits now are, this has to be a 8, this has to be a 5, this has to be 1, and this has to be 7. And that's how you solve it. Pretty interesting notion, particularly this mod length region sum line. Never ran in, I mean, this is the first time I've run into this rule set. It's very interesting, though, the logic that's required for that then. And then the arrows limit things, definitely. Like this. It's like, oh, this has to be all 3 here. Pretty interesting rule set, and just actually the loop was very interesting too, with the arrows. Pretty cool puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.